Hey there, Algebra 1. We are in lesson 6. We are talking about equivalent equations right now. I'm at the Jones Center. My youngest child is swimming. So, strange atmosphere. I believe I should be wearing my mask, but there's nobody around except the people that walk past, so I think I'm okay. All right, equivalent equations. Okay, we see equal. So equations that are different, that maybe look different, but they're equal. So let's investigate what makes two equations equivalent. Remember, that means equal. Two different equations that look different but are equal. So let's warm up. Your teacher will assign you one of these expressions. Evaluate your expression when n is those things. So we're going to do two of them. I'm going to pick a positive one and a negative one. And we're just going to, it says evaluate your expression when n is given. So I'm going to substitute. So instead of n, I'm going to write 5. That's 2 times 4 minus 3. So 5 squared is 25. First we do 4 minus 3, which is 1, and times 2 is 2. So that gives us 25 minus 9, which is 16 over 2 is 8. Okay, let's try it. Let's try the other one. Well, no, let's try negative 1 in the same equation. Okay, this always takes a minute. I just wrote really big, so I'm out of space. I do wish I could just lasso it and make it go away. All right, let's try it with negative 1 now. So instead of n, we're going to do negative 1. So negative 1 squared is 1 minus 9 over, let's see, 4 minus 3 is 1 times 2 is 2. Negative 8 over 2 is negative 4. So when we did this one, I think I got 8. Negative 4. So let's do the same thing, the same input with the other two equations. As soon as I'm done erasing. I'm sure there's a better way. I'm going to write smaller with these next two. You watch. All right, so 5 in here. 5 plus 3 times 5 minus 3 over 8 minus 3 times 2. So 5 plus 3 is 8 times 5 minus 3 is negative 2. No, positive 2. I'm not sure what I was thinking there. And here we do PEMDAS, which is parentheses, exponent, multiplication, division. So 3 times 2 is 6. 8 minus 6 is 2. So this goes to 1, and the answer is 8, which matches that one. Now let's try it with negative 1. So negative 1 plus 3 times negative 1 minus 3 over 8 minus 3 times 2. So negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4 over, here we have 3 times 2 is 6. 8 minus 6 is, 8 minus 6 is 2. So we have 2 times negative 4 divided by 2, which is 2 times negative 2, which is negative 4. Sorry, for a second there, I didn't think I'd get the same thing, but I did. So we did it. I had two different equations that when I plugged in one value to each equation, I got the same answer. Another value to each equation, I got the same answer. Okay, that actually means that those two equations are equivalent. Okay, they're equal because no matter what I input into n, I get the same output. They provide the same solution. Okay. Were you surprised that these expressions have the same results for different values of n? I was. I mean, I know that's what we're learning, so I really wasn't. But those equations, if you look at them, look so different, yet they provided the same solution. If or when you tried using other values of n, what did you find? Well, we tried just two, but I'm going to say no matter what n is, you get the same answer. Do you think that the two expressions will have the same value no matter what the value of n is used? Yes. I mean, we tried a positive number, we tried a negative number. That's really the two different inputs that we need to try. I could try decimals. It doesn't matter. We'll see how we can get this video done. I have very low battery left. May have to finish it later. All right, consider the equations you wrote for each situation. Were they all equivalent? Why or why not? There's something missing there. Hold on. That's activity 1. Okay, those got out of order, so don't worry about that slide. Let's do this slide. Write as many equations as possible that could represent the relationship between the ages of the two children in each family described. Be prepared to explain what each part of your equation represents. So for family A, the youngest child is 7 years younger than the oldest, who is 18. So for family A, the youngest child is, see how I did that? When I said the word is, I wrote an equal sign, which is very normal. The youngest child is 7 years younger than the oldest child, who's 18. Okay, the youngest child is 7 years younger than the oldest child, who is 18. Y equals the age of the youngest child. 18 equals the age of the oldest child. In family B, the middle child is 5 years older than the youngest child. So in family B, the middle child is 5 years older than the youngest child. So M is the age of the middle child. Y is the age of the youngest. Okay? Number 2, Tyler thinks that the relationship between the ages of the children in family B can be described with 2m minus 2y equals 10. Where m is the age of the middle child and y is the age of the youngest. Okay? We did m equals y plus 5. Okay? Where m is the age of the middle child and y is the age of the youngest. Well, if I take this equation and multiply everything by 2, I get 2m equals 2y plus 10, right? Now, if I move the 2y to the left side of the equal sign, I can say 2m minus 2y equals 10. So I just took our equation, multiplied everything by 2, and then subtracted 2y from both sides, and got the exact same thing that Tyler got, right? So Tyler's right. because we have equivalent equations there. Are there any of these equations equivalent to one another? If so, which ones? Let's see. If I take this one and I divide both sides by 9, I get 1 equals 3a over 9. Now that fraction I can actually simplify. It's the same as 1/3 a equals 1, which is the same as this equation. Now this equation, I can multiply everything. Let's get those lines out of there. I could actually multiply everything by 9. If I multiply this by 9, I get 9a over 3 equals 9. Just distribute it. And this fraction simplifies to 3a equals 9. So if we want to look at this one and that one, we're equivalent. And if we look at this one and this one, we're equivalent. All right, now let's check out the other two. This equation, 3a plus 6 equals 15, and then a plus 2 equals 5. Well, I see my a's are 3, so I wonder what happens if I multiply this whole thing by 3. Need some space. So if I distribute this through, I get 3a plus 6 equals 15, which is equivalent to this one. Now I can take this first equation and divide everything by 3. This gives me a plus 2 equals 5. And these two are equal. So I can manipulate them with math, with valid moves in math, and have equivalent equations. How can we show that a equals 1 is equivalent to 3a equals 9? I can't. Yeah, I can't. Hold on. This is out of order again, so this slide doesn't belong here. So we are going to ignore it because that's what we're going to do. I see. I think this is supposed to go up here. Okay, I'm not sure where they're supposed to go, so it's fine. Okay. So activity 3. Noah is buying a pair of jeans using a coupon for 10% off. The total price is $56.70, which includes $2.70 in sales tax. Noah's purchase can be modeled by x minus 0.1x plus $2.70 equals $56.70. Okay, how does this equation represent Noah's purchase? So it looks like x equals the original purchase price, the original price. Okay, and then if we take off the 10%, this right here is 10% off coupon. Okay, and this right here is plus tax. And this is how much Noah spent. Okay, so the original price minus the 10% off coupon plus the tax is how much Noah spent. Okay, what does the solution to the equation mean in this situation? Okay, hold on a second. So in this first one, what does the solution to the equation mean? The solution is the value of x that makes the equation a true statement. And in this particular case, it is the original price of the jeans. Okay, it tells us the original price of the jeans. How can you verify that 70 is not a solution, but 60 is? We can plug in 70, right? So I can say that 70 minus 0.1 times 70 plus $2.70 equals 56.70. Okay, and I have my calculator out. I'm back. So do this math. 70 minus parentheses 0.1 times 70 plus $2.70. Okay, that gives me, on the left side is 65.70. Sorry, my pen's messing up a little bit, which is not equal to 56.70. Okay, let's try 60. Let me change colors. If I plug in 60 minus 0.1 times 60 plus 270, what do I get? 60 minus parentheses 0.1 times 60 close parentheses plus 270. I get 56.70. Okay, so that's how we verify. We plug them in and see which one gives us a true statement and which one does not. 70 was not true. 50 or 60 was. Okay. Here are some equations that are related to the original equation. Each equation is a result of performing one or more moves on that original equation. Each can also be interpreted in terms of Noah's purchase. For each equation, determine either what move was made or how the equation could be interpreted. Some examples are given here. Then check if 60 is a solution to the equation. So here I have, so my original equation's up at the top. Here I have 100x minus 10x plus 270 equals 5,670. So what was done? I multiplied everything by 100. Okay. My interpretation is the price is expressed in cents instead of dollars. And do I get the same solution? So I'm going to do 100 times 60 minus 10 times 60 plus 270 and see what I get. Plus 10 times 60 plus 270. I did not get the same answer. Yeah, it should work. So 100 times 60, because 60 was the solution. Oh, minus 10 times 60, my bad, sorry. Plus 270. It is 56.70. Okay, it is the same solution. Yes. So here we have x minus 0.1 equals 54. So what was done? We subtracted $2.70 from both sides. So let's check. Oh, here, this is the price before tax. So we have 60 minus 0.1 times 60 equals 54. That's 0.1 times 60. 60 minus 0.1 times 60 is 54. So that is a solution. Okay, equation C. Here, we had the original price minus 0.1x. We collected like terms and got 0.9x plus 270. Okay, this 10% off means that you're actually paying 90% of the original price. 90% of the original price plus sales tax is $56.70. Let's try it. 0.9 times 60 plus $2.70. And that is $56.70. So paying 90% of the price is the same as 10% off. All right, we're still going. Okay, equation D. The price after using the coupon for 10% off and before sales tax is $56.70. So we aren't talking about sales tax right here. So that would be 60 minus 0.1 times 60. Is $54. It's not the same. Okay, this is the price after using the coupon and before sales tax. So it can't be the same because we're not including sales tax. We need to include sales tax to get the same value. I'm so sorry. So if I add $2.70 to that, I get $56.70. Okay, here,